This is VSM Studio.
Okay.
You can see this option. It's showing
Source
source
code.
code,
Yeah.
right? So here you need
Yeah.
to go. Now whenever you want to install something, like if I want to create a project for any controller, I'll show you how to install the particular software first. Just click on create project and select your for which microcontroller you want to work with. You can see here there are so many softwares. Here you have Raspberry Pi also, PIC controllers, MSP430, Cortex M4, M3, AV, ARM7, Arduino, and all other controllers. Now when you want to work with AVR controller, then in AVR family we have these many controllers available.
Okay.
Okay, so I am selecting Atmega 16. So simply select this, and then what you need to do is, here it will show you which compilers are available. You can see this here, it is not configured. Here also it is not configured, right? Here these compilers are not configured, so we need to configure it if you want to work with it. Only for assembly the Proteus is already configured. Hello?
Yeah.
So we need to configure this. If I select on some WinAVR, it will see that compilers, and it will say that WinAVR is not downloaded. You can say
Okay.
here. So simply download it, and it will ask you. Similarly, if you want some other compilers, you can download all the compilers for GCC, ARM, high-tech compiler, Keel compiler
Okay.
for ARM, MPLab, any source code, whatever you want, you can compile it, and you can install it. I mean, whatever compiler you want, you can install it. And even you can execute Python 3 also in this, because sometimes you are running on Python controllers which supports Linux.
Okay.
Just to select OK, and then for WinAVR. Next, agree the agreement where you want to install this.
Okay.
Install files, add directories to the path, install programmers, notepad, install. Okay, till it install, I'll show you how your microcontroller will be for Atmel AVR series. Okay, so what is the pin diagram and everything we'll see till that time, rather than wasting time. Okay, you are able to see Atmega 16 pins?
Yes.
Okay, so now here if you see, this is also a 40 pin controller. Here in again the Atmega 16 or 32 says you that 80 specifies that it is from a company called Atmel. Mega is a family of controller. Here you have tiny controllers, mega controllers. So this Mega is a family of controllers, and it is a 16-bit IC. Okay. So here you can say, here you can see HTML 16 or 32 specifies that this is the name. Name is actually, every name will have some specifications from which you can draw some output. Okay, so here this is an HTML IC, and this is also a 40-pin IC. If you see 10th pin is a VCC, which is power supply, and 11th pin is ground. Okay, and similarly you have Extal1 and Extal2 on 12th and 13th pin, which specifies you have to connect, if at all, if you are connecting an external oscillator, then you will have to connect the external oscillator in this, between these pins. And you have three more pin called 30, 31, 32 as A VCC, A ground, and A reference. Why? Because here we have inbuilt ADCs. If you remember, when we connected external ADC, we had two different pins for A ground. We had two grounds, two separate grounds we had. Right. So here also we have two separate grounds. One for digital ground is our normal ground, and here we have analog ground. And then we have a separate power supply for your ADCs, and one reference voltage for your ADC. Next, here also we have 4 ports, and here we are calling, rather than calling P0, P1, P2, P3, here we are calling it as PA, port A, port B, port C, and port D. Now, in 8051, port A, port 0, port 1, port 2, and port 3. Except to port 1, all the other ports were having some alternate functions. Here you have no free output, free pins. Here either all the ports do have two works, or you can say two alternate functions. One is either work like input output, or work like some other particular alternate functions. For example, here if you see on port D, the functions, alternate functions other than input output pins are RxD, TxD, which belongs to your UART. Am I audible?
Yeah.
Yeah. Okay. So here this RxD, TxD belongs to your external, UART. Interrupt 0, interrupt 1 belongs to interrupts. Then here you have OC1, OC2. This is for output comparator pins. Similarly, here you have this is IC's input comparator. Then if you go for port B, then you have here T1 as timer 0, T0 as timer T0 timer 0, T1 timer 1, and here this pin is provided again for interrupt 2, output comparator 0. Then you have these 4 pins, SS, MOSI, MISO, and SCK. These 4 pins belongs to your SPI protocol, serial peripheral interface. Then go for port A. These all 8 pins belongs to your ADCs. That means rather than having some different IC, directly we can connect our sensors here itself.
Okay.
Okay. Next we have port C. In port C, the alternate function is like SDA and HCL. They belongs to I2C protocol. And others are for timers. That we will see. Okay. So in this way, if you see, the basic structure is like, here you have 4 ports. If you see PIC controller, they have 5 ports. And all the ports, it's not necessary that all the ports should have 8 pins. Okay, they may have. Now if you see PIC controller, in one port you have 8 pins. In one port you have only 5 pins. So it's not necessary that you should have same number of pins in all the ports. Okay, so this is the basic AVR controller. Now if we see the, I think we would have downloaded this till now. We will see this once. Where is it? Right. So recheck for, it is already installed. Simply checking it once. Saying yes. Okay. Now WinAVR compiler is there, and we can select it WinAVR. Okay.
Yep.
And then simply create OK. And here is our file.
Yep.
Fine. Now here we need to write our main program. So to write our, here we need not write all those already all the include header files and everything is included in this, so we can directly start writing our program. Now the one big difference between this AVR and microcontroller, other microcontrollers will be your AVR microcontroller and 8051 microcontroller. 8051 is bit accessible. That means you can work on single bit without disturbing all other port pins, right? But in AVR or ARM or STM32, you can't work on single pins. You will have to work on whole port even if you want to work on one single pin.
Okay.
Okay.
Yes.
So here what we will do is, here what we will write one program for this is like simple same thing, while of 1, what I'll do is write toggle one whole port,
Okay.
and here I'll be writing it like for port B. For port B I'll just write port B is equal to not of port B. Okay, if you write this, then what happens is if your port B value is 0, it will become 1. If it is 1, it will become 0 simply. Okay, so here you have some build option, build project. It build with an error, and that error is I have not written semicolon, so just to simply place a semicolon here and build it again. So it has built successfully. I am rebuilding it. It compiled successfully. Okay, now if you want to run it, you can again run it in two different things. First of all, we can run here in simulation debugging mode and the other in simulation mode. Okay, so first we will debug in here only. So here when you are debugging, you can see that here it is showing some options called run, step over, step into, step out and step 2. So here we can use any of it, like if you run it, it will run continuously. If you are saying step over, it will come out of the loop and it will not show us step by step what is happening in particular function or loop. Then if you go for step into, it will show you step by step at each step what is happening, and step out is just completely come out of it, and this is for step 2 particular line. Then you can use this. Now we will use this, but before that we will simply check out the peripherals here. So here we are able to see that or not. I'll just check it out because I think we'll not be able to. So we will simply step into and we will see here. Step into. Okay, directly it is running. So here if you see this port B, it is continuously toggling.
Okay.
Is it
Yeah.
visible?
Yes. Yes.
Okay, so it is continuously toggling, so it becomes simple to
Hello.
Am I audible, Kashif?
Yeah. Yes.
Okay. I think it is due to that
You
Proteus
need to update.
software.
Okay.
Proteus software, it got stuck. Okay. Okay. So what I was saying is, similarly, you can just install the similarly what you can do is you can install that, and you can write programs like port A equal to 0x55, port A equal to 0xFF in the similar way how we toggled this 8051. Okay, but to work on bits we will have to check out how to do that. Okay, but for that you will have to understand one concept called masking. So if you want to write or use some particular bits, you will have to work with either ones and zeros. Okay, so here if you see this, you have some and operation, right? So and chart is like 0 0 is 0, 0 1 is 0, truth table for and operation, and 1 1 is 1, right? That means
Yeah.
if I have something like, I'll get only 1 when both the options are 1, right?
Yeah.
Rest of the time I'll get zeros only. Okay, now if I want to work on, suppose, second bit of my microcontroller, at that time I don't know what is the value of my second pin, so I am assuming like all the bits are zeros except the second bit. Okay.
Okay.
Hello.
Yeah.
Okay, so now what I'll do is I'll simply do AND operation with 0 and AND operation with 1. Now when I do it with 0, what happens? Now don't see all other bits. Anyway, as you are doing AND operation here, if it is even 1 also, it will become 1 and with 0 is 0. But we are interested only in this
Okay.
particular second bit. So now if this second bit is 1, 1 and with 0, you will get 0, right? Irrespective of this second bit is 1 or 0, you will get 0 only. And if you do AND operation with 1, at that time, here if you have 1 and with 1 you will get 1. And here if you are doing AND operation, here if it is 0 and with 1 you will get 0.
Okay.
If your second bit is 0, and if you are doing AND operation, I'll do like here, if I'll write 1 1 1 1 space 1 1 1 1. Now if I do like this, at that time if this second bit is 0, you will get something like 0 and with 1 is 0 only.
Yeah.
If I have something, my input is 1, at that time 1 and with 1 is 1.
1.
Okay, so basically I am just trying to use this one particular bit. Rest of it, now if you do AND with 1, what happens, what output you are getting? If we are interested only in second bit, but we are not changing other bits also. You have 8th bit as 1 AND
Okay.
with 1 we are getting 1 only,
Okay.
right? So
Yeah.
and other bits we are getting 0 0 0 0 1 0. Now if you see this, here only this second bit we are changing, rest of the bits are all same.
Okay.
So to change one particular bit or to observe one particular bit, we will have to do AND operation with all ones, such that all other bits are not disturbed. Here this is 1000 and this is also 1000 only. We are not disturbing it because we are doing AND operation with 1. We are using only this second particular bit. Rest of it bits will be same. Here if this changes to 0, we will get here all zeros. These bits will become all zeros. Here if we have 1, you are getting 0 0 1 0.
Okay.
This is the concept of working with your all other controllers where wherever the controller is not bit accessible and byte accessible.
Okay.
Okay, like we were using something like S bit in 8051 and we were writing bit LED is equal to some particular pin, right?
Yeah.
Here and there we were simply writing LED equal to 1 and LED equal to 0. Here we can't do that.
Okay.
Here this option is not available. So if you want to work on this, we will have to work it in this way.
Okay.
So we will be writing it something like full port. We will be doing operations on whole port, but we will use only the second bit.
Okay.
Okay, so for that, here what we will do is, here I'll write it like okay, this rest of things you can see it your way. I'll simply show you. Here see, here 12 machine cycle is not 12 pulses is equal to not 1 machine cycle. Here 1 pulse is equal to 1 machine cycle. Okay, that everything you will have to check it in your data sheet.
Okay.
I'll just give you some references. You just go through it once and you say it. Why I am going to this microcontroller is because I want to show you one basic operation, as well as we want to go for your SPI and I2C.
Okay.
Okay. Now suppose we will toggle only 4 bits. of a microcontroller. So how we are going to do it is port B. I'll just remove this and I'll write, or you just toggle 3 bits or 2 bits, I'll simply write like port B, or operation we will do, or with what I want to do, I want to make all the bits zeros. Okay, so I'll write 0B because you are writing in bits format. 0B, 0 0 0 0. I'm writing all, I'm all making zeros. Okay, so here you will be writing it like 0 0 0 0, and then what I'll do is next operation I'll do like port B equal to port B or with 0B. You can do either or operation or and operation. And operation will make it like all zero, if at all, if all ones are there, all ones. If in or operation, even if it is 0 or with 1 is 1 only. So here I am writing all ones. So first or operation it will make all zeros, and second or operation it will make it as all 1, but this will execute only once. Why? Because already when it becomes 1 and you do or with 0, again it will become 1 only. So this will execute only once, and your final output will be like all ones at 4 bits. Okay, so to avoid this, what we will do is we will do AND operation. So here what I'll do is AND. Now what will happen? First you are making all the bits as 0.
Okay.
Okay, here what I'll do, all the bits I'll make it as 1 1 1 1.
Okay.
Now here if your bit is 1, it might be somewhat confusing at starting.
Okay.
Now if you see this, what we are doing, we are not using only AND operation, we are doing here, we are using two operation, one is OR operation and one is AND operation. Okay, so here what it will do is it will make 4 bits as 1. Okay, first 4 bits it will make high.
Okay.
Okay, and then what we are doing here 4 bits, we are doing AND operation with 0. So 1 AND with 0 is
0.
0. So here we will get all the 4 bits as low.
Okay.
But to repeat its operation, we have to again OR with 1, because again if we'll do AND with zeros, once it becomes 0, 0 AND with 0 will become 0. So that's why we are using OR operation here. Okay, so whatever previously we wrote, port B is equal to not of port B, this will have same option, but here we are using only 4 bits. If you want, you can use only 1 bit or 2 bit also, that also we will see once. But I just fear that my system is using, I don't know whether this will again if it gets stuck or what. Why? Because this after running this particular software, it is just hanging my system. So I'll check this once again and I'll show you, but let's see. See, it's showing, till now it is showing perfectly. If you see port B, only 4 bits are becoming high and low, right?
Yeah.
Rest of 5, 5th, 6th, 7th, 8th are not working, they are low only.
Okay.
Is it fine?
Yeah.
So in this way, if you do same thing here, Now if I say, I think this got stuck again, and it may end my call also, and I'll have to join again. Yeah, it is showing this program is installed correctly. Okay, so this stopped. There is no problem with this. Now I'll write some more programs, but before that, again it is installing my software, so I'll explain you some other things here. If you want to, I'll just write the program in this and I'll show you. Now if I want to toggle one bit, at that time what I need to do is, here I'll simply make it like 1 bit 1 and 1 bit 0. So here the simple thing will be, in place of this you just write it like 0 0. So only first bit and fourth bit will work, toggle. Or if you want to toggle only one bit, at that time simply do this operation OR with 1 and then AND with 1. Okay, so in this way you can do. And one more way is there of writing this. Okay, that is using shift. This was using OR operation. Okay, now we will do it using shift operation. Okay, now here, but here we have one register. Directly we can't use this pins. We will have one register called DDR register. Okay, that is data direction register. There, whenever you are using particular port for input, you will have to say that this is working like an input. So for that, what we will do is, now I'll remove this program and I'll write one more program to show you that thing. So first what I'll say is, I'm connecting something like at port B, I'm connecting my input DDR B. DDR is, as I said, data direction register. So here I am declaring that my some 8th pin is going to work like an input. Okay, so for that what I need to say is DDR equal to DDR B. As I said, if you want to make it some bit 1 or 0, you need to use AND operation, right?
Okay.
Hello?
Hello. Yeah.
I'm audible, right?
Yes. Yes. Hello.
Yeah, yes. So here what I'll do is, I'll do this AND operation, and one second, again it got stuck somewhere. So here what I'll do is, I'll just write it like DDRB, and with, here we are writing something like not of 1 less than 7. Now what happens here? First of all, you are shifting, you are using 1. Okay, so here 1 is nothing but 0 0 0 0 0 0 0 1, right?
Okay.
1 is this one. Now I am shifting this one 7 times, left shift. So when you shift this one 7 times, it becomes 1 0 0 0 0 0 0
0 0 0 0. Yeah.
right? And then I'm saying that just make this whole thing a not 1. So here what happens then? Here it will be like, when you say not of this, you get 0 1 1 1 1 all ones, 1 1 1. Okay, so particularly only 7th bit you are making it like 1, 8th bit you are making it like 0.
Okay.
Okay, rest of the bit we are not making it like input. It is whatever it might be. It might be first pin might be input, second pin might be output also. So here when you want to make particular pin work like an input, you need to give a low value to it, and you are making it this way without disturbing all other pins. So here when you give one, it might be output, it might be input. I don't know for what reason you are using that. Okay,
Okay.
now I am making this work like an input. So here when you want to work with one particular pin, here you can use even pin B option. So here you will have to write your program like, if we are using only 7th pin, right? So here you will have, if my pin B. So here for port you will have 3 registers. One is port register, one is DDR register, and one is pin register. DDR register we
Okay.
will have to say that whether you are working like input or output. Okay, whenever you are using by default all are high, so it will be like output. So whenever you want to use input, you will have to declare it in DDRB register. Next you will have
Okay.
port register where you can have values. Okay, and pin
Okay.
register is used to monitor whether that particular port or pins or bits are high or low. So generally you will use pin B along with input to monitor. Now my pin B is nothing but an input, which is like switch.
Okay.
Okay, so my 8th bit is switch, and I am writing like, if pin B, which bit we are using is your 8th bit. So here we will write pin B and with 1 less than 7. So I don't know what my pin B contains. What our pin B contains is this value.
Okay.
Okay, that means by default it is 0.
Yes.
By default it is 0. Here you have 0 1 1 1 1 1 1 1, and you are doing AND operation here with this particular 1 shifted 7 times.
Okay. 1 0.
So here you will get something like 1 0 0 0 0 0 0 0. So here first you are seeing that you are doing AND operation of 0 with 1, and you are seeing what happens. If at all if this is there, what we are doing is, I am making one particular bit as high or low. So I'll write it something like port B is equal to some value, whatever you want to do. Port D is equal to 0x55. Else, or you can see else condition, you can write it like port D equal to 0xAA.
No.
Now if we run this, first of all we need to build it, whether do we have any errors or not. We do have an error, which is again a semicolon. We have not written semicolon here, so we will simply write a semicolon here. Here you have those options also to build as well as to rebuild the project, and then we have debug option, run the simulation. See here by default this port D contains else operation, so we will simply connect a switch here, which is our button option. Here we call it as button. So when we connect a button at port B 7th pin, which is nothing but 8th pin, so when you run it, now here this is 0x AA, and when you click on this, it should become 0x55. See,
Okay.
in this way you are going to work with this particular thing.
Okay.
Okay, now if this is clear, we will not be able to go through all the things in this, but basic I wanted to explain you this because of I2C and SPI protocol.
Okay.
So we'll directly jump over there and I'll explain you that particular concept.
Okay.
Now, first we will go with either I2C or SPI, anything is okay. Okay, we'll go with SPI first and then we'll go with I2C. I'll
Okay.
explain you the so what is SPI is your serial peripheral interface. Okay, so here this is also one particular protocol like your UART protocol. So basically your protocol here also will be same, protocol will be same, but what will like implementation of that particular protocol will be different with different controllers, but concept of that particular protocol will be same.
Okay.
Okay, so here what is that was for, so why you use this? When you are using this, you can connect to so many devices which work on SPI. That means if when you are working with, suppose, okay, you have seen a what I2 sorry, displays, right? We have seen alphanumeric displays. If that display supports SPI or I2C, we can directly use this protocol to display the device, display the data on LCD also. We have I2C LCD display also. So
Okay.
whichever devices support that particular protocol, we can use it to interface it with it.
Okay.
Suppose if you are using I2C protocol to display on LCD, okay. Now what happens? Why we should go for it? When you are connecting your LCD, how many pins we are connecting? We are interfacing 10 pins, right?
Okay.
Okay. So already we have 4 ports. We have 8 pins. So 4 8, 32 input output pins are available. But we are using 10 pins to connect LCD. Suppose I have one operation or one project where I have to connect so many devices. So at that time, spending those 10 pins there might not be easy for me. So rather than looking for other operations, if I have that cost availability, that okay, fine, if I can do this, then at that time what happens is, if you use I2C display, at that time instead of 10 pins, you will have to use only 2 pins for LCD.
Okay.
Okay, so in this way you can have this particular thing. Now the other thing you can use is, suppose you are using external SD card. So SD card might work on your SPI protocol. So you can simply use this protocol and use that SD card. This was started originally by Motorola company.
Okay.
Okay, and many all other companies are using this standard again, and it uses 2 pins for, actually this is a 4-pin protocol. This uses 4 pins. Already we have seen in this pin diagram. Here this uses 4 pins, like these 4 pins it uses. Okay, 86. Yeah. You're able to see pin diagram?
Yeah.
In this port B, you have this 4 pins called SS, MOSI, MISO, and SCK.
Okay.
Okay, these 2 pins are used for sending and collecting the input and output. This is MOSI and MISO. Master out, slave in. Master in, slave out. These are the pins we are using to send the output and collect the input.
Okay.
Okay, and this is using SCK is your clock pin and SS is your slave select. Why you are using slave select and everything, I will say you. So this is basically, you can call SPI as 4-wire interface also, because it uses 4 pins. Okay. next you have something like this. If you say another image, if I have downloaded, I'll show you basic frames. No, this is not timing diagram, is interconnection. Okay, so you see this, you can see this, right? The next image, SPI master slave interconnection. One here you will have two things. One is called master and the other is slave. So whoever is generating clock, here this is a synchronous mode of communication because everything works with respect to clock. One master will generate a clock and that clock is used by other one to work on that particular communication. So your master will be a clock generator here.
Okay.
You will have a register of 8 bits and here slave will also. So if you say, suppose you are using something like ADC or some SD card option. So here your microcontroller becomes your master and your SD card interface becomes your slave.
Okay.
Okay, so here slave will also have some register and master will also have some SPI. As we are using SPI communication, you will have some registers. So here it will have some 8-bit shift register and here also. So here clock is generated by master and you are providing it to your slave. So when you say master in, slave out, which means you are receiving an input from slave because slave is using output operation, and as you are receiving it in your master, you call it as master in and slave out. Similarly, if you are sending some data to your slave from master, you call it as master out and slave in. And you may have many number of slaves. You can connect to 2 SD card or 3 SD card, or you can connect some ADCs or DACs or some other particular devices to your microcontroller which uses SPI operation. At that time, if you have 3 to 4, you will have to use this SS. SS is slave select, with which slave you want to work with or with which slave you want to communicate right now. That particular slave you will have to select. SS0 becomes low, which means whenever you make that particular bit as low with some register slave, it will select that particular slave. You will have to make it low for that. So here slave select is to use that particular interface or particular device. Clock SCK is your clock generator which you are using for all the operations, which will provide clock for all other slaves also. Master in, slave out and master out, slave in is used to select whether you want to send output from slave to master or from master to slave.
Okay.
So here this is a shift register which we use. So one input when you say send or when you receive it, you will be receiving and it will be shifting it 1 bit by 1 bit. So if you are receiving it something like master input, so at that time first you will be receiving it in LSB and then it will shift. When you get second bit, it will shift it to second bit. That means your bits will be shifted when you receive some new bits.
Okay.
Okay. Then you will have two options here. As you are receiving and you are having input as well as output, you will have two things. One is you can either read or you can write. So there might be some operation where I want to, suppose you have SD card. Okay, when you are using SD card, you can store information in it or you can retrieve information in it from it. So when you are storing some information in SD card, you will call it like I am writing into SD card. And when you are retrieving some information from SD card, you call it as I am reading from SD card. But in both the cases, the clock generator will be with master only. Okay. Now, here SPI works with some particular something called, you can say it like clock, right? When you say clock, you will have some polarity for clock. The polarity as well as phase of the clock must be same when you are communicating. If you will have some different polarities or different phases, at that time you will get some wrong data. What is that polarity and phases? I'll show you. Okay, if you see this control bits, you will have something like clock polarity and clock phase. But here also I didn't do that. Okay, just to see this first, you will have a register here also with respect to per SPI. Okay, like we had for timer, we will have for serial communication. Like that, we will have some particular registers for SPI also. So there we have two bits called SPR1 and SPR0. Okay, which is like SPI pre-scalar or SPI frequency. As you are using something like 00011011, you will, as you have 2 bits, you will have 4 combination, which says that your system clock, whatever system clock you are using, it might be 16 megahertz or 11 megahertz or 12 megahertz, that system clock will be divided by 4, 16, 64, 128. Why? We will see that later, but for now I'll say you this is your frequency which you are selecting. Here you can have variable like you per UART you had different frequencies of communication, right? For 1200, 2400, 4800, 9600, like that. Here also we have various frequencies of communication. So here you can select that by using this particular pins. Okay, and clock polarity and clock phase, I think I don't have that. Just a second, I'm just checking it out. Okay, you are able to see this image, right?
Yes.
Hello?
Yeah, able to see it.
Okay. So now if you see what is this clock polarity and clock, what is clock polarity is, if you see clock polarity as 0, your clock is starting from low to high.
Okay.
Or you can say that you will have something like clock polarity in this way, like for here if you see this red line at starting, this is going from low to high, and if you see clock polarity as 1, it is going from high to low. First red line, if you observe, at clock polarity 0 and clock polarity 1, your clock is starting from first. If clock polarity is 0, at that time your clock is like low to high. And when you say clock polarity as 1, your clock becomes, it starts from high to low. That means all the operations has to be done with respect to only one thing. Like I cannot do something like when clock polarity is high to low, I can do one operation. When the clock polarity becomes low to high, I will do second operation. It's not like that. So if you are selecting clock polarity as low to high, at that time all the operations has to be done with respect to, whenever the operations has to be done only with when clock goes from low to high. Okay. If at all, if you say phase, then you have to select the phase like we can send, read or write only when your clock is something like you will have two phases here, phase 0 and phase 1. So here when you have this bits as high, at that time only you can change or shift the data. When you say phase is 1, at that time you can do that only when this clock becomes high to low. You will have 4 options here. When clock polarity is 0, phase is 0. Clock polarity 1, phase here. So when this, if you see only clock polarity is 0 first, you see, when you see clock polarity is 0, at that time your the wave is from low to high. Now if you see only red lines, observe this phase 0. Here your data is changing only when you have clock from low to high, and polarity is low to high, as well as your cycle is, it is changing only at high. If you see 1, 2, 3, 4 at red lines, it is simply high. If you see phase 1 clock polarity 0, at that time if you see this, the data is changing from when your cycle changes. If you see this particular, I am unable to select it, but here when your cycle is shifting from high to low or low to high, at that time only you can change your data.
Okay.
I think it might be somewhat confusing for you.
Yeah.
Is it clear or is it confusing?
Just want to know if it is in the middle, it is changing, or the blue line.
It will change when it is in middle, when clock phase is 0.
Okay.
When clock phase is 0 and phase is 1, at that time it will be changing in between. And if it is clock polarity 0, phase 0, it will change it when it is either high or low.
Okay.
Okay. Similarly, when clock polarity is 1, at that time you will have something like from high to low. At that time, when clock polarity phase 0, it will change. If you can see that blue line is your, if you see, you will have something like it will change at in between, and it will be one at high or low.
No.
Okay. You will understand it when we write your program.
No.
Or else I'll simply draw it on board and I'll show you if this I mean with the different clock polarities, that will be easy for you. I'll complete this topic and we will then end it. Why? Because so here when to read and this is for reading operation. Okay, you understood, I guess. And you call this as 4 modes: SPI mode 0, mode 1, mode 2 and mode 3. So we will first, once again we will just confirm it. When clock polarity is 0 and phase 0, at that time when you have rising edge, that means low to high, at that time you will read. And when it is low, high to low, at that time you will, that is a transition.
Okay.